Yeah, thanks for coming to my talk. Whether you're here or watching online, we appreciate you, of course. Abusing the Microsoft Identity Platform or exploring Azure AD token caching. I guess that should be like Entra ID now, although I don't think that's a better name personally. But there we go. Just a little bit about me. I'm Ruben, as you can see on the slide. And I work with Valentina, who did the keynote today. We're both on the Adversary Services team at IBM, doing like red teaming work or research, like in function of, red teaming work for our clients. You can see some extra stuff about me as well. I'm a Windows shill. It's true. Windows is like the best thing since sliced bread. And some extra like areas of interest that I have, mostly like post-exploitation, reverse engineering, and vulnerability research. Good. So we just have like a small introduction here. What we're talking about today. So obviously we're talking about how native applications authenticate on Windows when they're like in like Azure AD or hybrid environments. We'll look at like JWTs, which are JSON Web Tokens, which are just like sort of authentication tokens that these applications use. We'll look at like what the post-exploitation use cases of those, and we'll see like how this is not really novel, but we'll get to that later. And then I have this secret agenda that I'm really pushing here, which is just to explain a little bit about how I think about doing offensive security research, like what that process looks like identify a question, do the research, and weaponize the product. Okay, so identify the question. So when we have to think about this, like where do the questions come from? I think there's sort of like three ways that might happen. One is like you're confronted with some new knowledge, right? Or you're looking at some new domain of knowledge, and there's this new thing, basically. The second one is like maybe you've been researching something for a while, and over time you've developed a better understanding about what that thing is, and because of that you've found out that you can apply some of that in some adjacent domain, right? So then new questions appear once you have a better understanding of something you've been researching. And then the last thing is like something has gone wrong, which happens frequently. So like maybe your team encounters some operational issue and they, need a solution for that. Or it doesn't even have to be a problem. Like maybe your team encounters this technology sometimes and they want to figure out like, how does that work? Can we use that somehow to our advantage during red team engagements? All right. So then we get back to this thing we're going to be talking about. And this started with a tweet by Mr. Docs, I guess, or I don't know what it's called on X now. We're all on X, which is bad marketing, I think. But yeah, he's talking about like when you dump Outlook, you might get sensitive information from Outlook and authentication tokens, right? And then we're in this first category, like of where the questions come from. For me, this was like I'm confronted with this new knowledge, right? Like there's authentication tokens in this memory dump that I didn't know about. But when you think about this, like this, it makes sense because many Office applications need integration with, these enterprise services. For example, if you're in OneNote and you save like a document that's going to get pushed to like the enterprise SharePoint, right? So OneNote needs to understand, like, how is it supposed to push that data? So it makes sense that it has, like, authentication data for, like, these services, that are being used, somehow. But they don't ask you for credentials, right? So there you go. Now, yeah, he has a blog post, which I've linked there, and you can have a look at that. He goes into more detail about, like, dumping these tokens, and showing, like, what they look like when you decode them and stuff like that. Just from a post-exploitation perspective, like, why is it interesting to look at this? Like, credential reuse and credential dumping is, like, very common workflow during a red team engagement. Like, the most common example is probably, like, dumping cookies from Chrome or something like that, getting that authentication data, and then accessing maybe some internal web applications as a user. And this is sort of like a redundant capability, right? Because sometimes you may have problems in this workflow. Like, let's say you dump cookies, but the user has only expired cookies, right? Or you recover credentials somehow, but the user has two-factor authentication. So this capability sort of overlaps with what we need and just rounds that out, essentially. So that's why I was interested to look at that. And of course, these tokens, like, bypass 2FA. So if you have the token, you're not going to have any issues if the user has 2FA. All right, so we identified this question. We figure out, like, this is probably something useful that we should look at. And then it's time to do the research, right? So the first thing I did was I wanted to validate, like, this assertion made by Mr. Docs. I don't know Mr. Docs, okay? So I wanted to validate that. Now, before I go into that, like, you can see at the top left, we have this little blob of JSON. And so that's, like, the start of what a decoded JSON Web Token looks like. And the reason I bring that up is because you see that it's, like, some well-structured data, right? You have, like, the curly brace, you have the quotes with TYP. So that means that when that token is base64 encoded, we know, like, what the starting characters are, essentially, of that token. In this case, it's like EYJ0, right? So what I did is I just look at that process. In this case, I used WinWord. So I looked for strings in memory, and then I did a regex, for EYJ0 dot plus or something like that. And you can see that we have 172 results. Many of these are just duplicates in memory, right? Some of them are invalid, but clearly there are JWT tokens here. So once we, like, validated that, we can start to think about, like, how are we going to operationalize this? Because what Mr. Doc said is, like, okay, you can create a process dump and then, like, search it for these tokens. But it's not great to do that, because, many EDRs are, like, very vigilant about creating process dumps of anything. So we want to avoid doing that if we can at all. The other idea I sort of put on this slide is, like, what I was thinking initially. Like, we could open a handle to the application and then enumerate the memory sections, and then based on, like, the flags of those sections, we can probably guess which ones might contain these allocated strings, and then, like, do some pattern byte scan. But it's not, like, a great technique to use as well. Like, there are some pitfalls there, and memory scanning can be intensive, and we might trigger detections that way also. Plus, that relies on the fact that one of these Office applications is running, right? So it's not great. All right, so anyway, I wanted to see like, but where do these tokens come from? They don't just appear in memory, by magic. And like the first thing I did was I wanted to understand if they were loaded from disk somehow, because I didn't want it to be like some weird COM thing or using RPC as something that was going to give me a headache. So I wrote like a function hook using like a tool I wrote, Fermion. It's like a Electron front end for Frida that's multi-platform. But yeah, what I do here is I hook create file W and I just print the first argument. So anytime create file W is called to either like create a file or open an existing file, I get that path. It just prints the path. And so I just restart Word and I had a look at the results to see if there was anything interesting there. Now there might be like 100 or 200 results that stream in, but when I was looking through these, I saw large blocks of these types of lookups in this path in app data local, Microsoft, token broker, cache, this sort of like a weird path, I had some weird feelings about that. Okay. So I decided to have a look at these files and you can see an example here. I've beautified this on the slide, but when you look like on the file system, it's just like a one-line string, right? But I've beautified it for you here. You can see some stuff in there, like some metadata about the file, like the schema version and stuff like that. You can see expiration timestamp, which is just base64 encoded. Some provider information at the bottom. It's like a big cutoff, I think. But it's like AAD broker plugin or something like that. And if you looked at some of the other ones, you'd see some interesting things as well, like SharePoint and that kind of stuff. And then you can see that there's this one element, response bytes, that has an attribute, it is protected, which is a Boolean set to true, and then like some value, which I've truncated here. But it's like a really big base64 string, like bigger than the entire rest of the file. So, there's some protected data there that we probably want to have a look at. And then if you look at this file, like, there's some things, to make you suspicious, like the provider name, like I mentioned, like some of them will be like SharePoint or something like that. And the fact that there's an expiration date tells me like, okay, maybe there's some authentication data here, like with expiration dates and everything. All right. Now, like if you've done any, like a lot of, or I don't know, a medium amount of development on Windows, you've probably encountered the Data Protection API or DP API, which you can use to encrypt, binary data, which can only be decrypted either by the user in the user context, or on the machine, like in the machine context where that data was originally encrypted. And that's like very useful, and it's used like in a wide variety of situations. Like Chrome uses that, for example, in the cookie store, as well. And so I wanted to kind of test that. And so I wrote another hook, for Word, where I hook, crypt unprotect data, which is the native API that's responsible for that decryption. And then I print out like whatever it's decrypting at that point. And you can see, I hope you can see, that, in the output, we have that same, base64 string, which starts with like EYJ0. So we know like it's decrypting those files and they contain our JWTs somehow. All right. So we identified this idea that's worth looking at, and then we did, we verified, the theory of the case, right? And then we did some research like on top of that to figure out like, is there a good way to operationalize that, so that we can use it, effectively. And then we need to weaponize the product, right? Yeah, so this is more or less what I did in code as well. Like here we take like one of these TB-res files. We just like read it. You could use like JSON deserializer if you want to actually get an object out of it, but you can just like regex it as well, right? It's not a very complicated object. So I look for is protected set to true, and then if that's the case, like I extract whatever the value is, so I can then pass it to the DP API to decrypt that data. And then something which isn't really clear here is that this data blob that gets decrypted is not just plain text. There's also binary data in there, intermixed with plain text. So I just in my code, I just run a regex over the results to get out the JWTs. You can see like at the bottom, I'm doing EYJ0 and I have some regex there. And then if you run that over all of those files, you'll find like many JWTs for a variety of stuff. Like when I did this on my enterprise laptop, you test in production, right? I found like 17 JWTs, and so you can see some of them here, like for Office, Graph, O365, SharePoint, OneDrive, all that good stuff. Yeah, like just because of our time constraints, like we can't, go through the structure of these JWTs, but I want to highlight this one part here, like when you base64 decode the JWTs, you're going to want to know like what kind of privileges they have. And so there's this element like SCP, which just has a plain text array of all the privileges that you can read. And there are some interesting ones here, like to read email, calendar. There's notes, and then you have other ones like directory access as user all, which gives you like 80 permissions and stuff like that. So this is a lot of privileges. Now, like it may not always be clear what these do, but I include the link on the slide, like graph permissions, the Merrill.net, which has like a really good detail on all of these, like what they are, which applications they're used for, where they apply. And so, my recommendation is to reference that, essentially. Okay. So then, like I made like the most primitive version of this, product, right? You can see it like on the right. Where I loop through that directory and then I read the files, I find the encrypted content decrypted, search for the JWTs, and then I print them out. One other thing I do here is like print out the payload of the JWT, because then you can see like what service they're for, and you'll be able to see the permission. So it just makes it easier from an operator perspective. Right? And like, this is easy to write. This is maybe like 50 lines of code or something. So, it's easy to write. It's in .NET. Like we have well-developed in-memory harnesses to execute that kind of stuff for years now. So it's easy to ship that as a capability, right? And also EDR doesn't seem to mind if you read these TB-res files. Yeah, that's probably an oversight. They should look into that, I guess. And we sort of achieve our objective. Like the tokens give you API access. So technically at that point you can take the token and, talk to the API, talk to SharePoint or something like that. But this is a low resolution musket, we're not delivering like something really good here. Like this is just a basic capability, I would say. Oh, okay. Yeah, and then I want to do a little diversion here, which is also a good lesson in doing offensive security research or any kind of research really. Like, when I arrived at, this stage, I understood more about like what I was doing. And then I did like a good search, with some good keywords at that point. And then I found that Adam Chester had like done this, he has a blog post, on that, and he has some like really amazing background research, on this topic, which I highly recommend that you have a look at. Now here it's not like a big problem because I lost maybe like a few hours of work by not, using my brain and searching online. But I think it's a good lesson because you might lose like a week of work if you're replicating some really complex task that somebody has already done for you, essentially. Good. But we have this low resolution musket that we. And it's not very nice. Like, maybe I can tell my teammates, okay, here's some tokens. Now you go and talk to the API. That's not like a very nice thing to say. Like, they're gonna suffer because of that. So I wanted to figure out, like, how can we use this? Like, how can we refine this product in a better way? There are two strategies, I think. Like, you can fabricate or manufacture your own TB-res file, like in a VM. Like, you could decrypt it on the target machine and then re-encrypt it and put it on your VM. And then technically, if an application launches, it will use those TB-res files. It's probably more complicated than that. Like, I didn't try it. I assume there's like going to be a bunch of problems doing that. It doesn't seem easy, but I'm sure like that should be possible technically to do that. And another idea is to hook crypt unprotect data in the process. When that gets called, when it returns, you just replace it with the data you stole from endpoint. And then like Outlook should say, oh, this is my session instead of the one on the machine. It's sort of the same idea, but I don't think these are really good options, because I just think like there's going to be problems doing that probably. But that should work, right? And then the other thing we can do is just, try to do what the applications themselves do and write like a small UI that talks to these APIs, and, we just write our own Outlook. Easy. That should be easy. And so that's what I did more or less. Like, I wrote a few single page web applications that, implement like a UI that does these API calls. And I'll show it like on the next slide. And then you have the docs here, for graph. It's not very hard to do that. And then I want to mention something as well, sort of related to what Valentina talked about this morning with AI, is that, if you go in ChatGPT and you say, hey, I want you to tell me how to use the graph to get a list of emails with this token, it will write you a function to do that. And it works. So it's obviously been trained on documentation, which is great news. Yeah. So I'll show you a demo of like Outlook and OneDrive. I've blurred some of it out because it's like on my corporate machine, but it'll make sense, I hope. So this is Outlook. You can see when we click, we get like a proper email content back because the API can give you HTML, right? So you can just render it just like in the client. You can do things like delete, you can get the calendar, whatever you want. It's sort of DIY, but it's pretty like feature rich. You can search also email on like keywords if you wanted to do that. And if there's attachments, you can download them, right? And this is Drive. You can see like we can get previews of files. I don't think you can even do that in Drive, but my client can. And then, yeah, if there's things like folders, you can navigate into the folder just like you could like in the web UI. Maybe it's a bit ugly, but like it does the work, right? Good, good. So yeah, so this is a much better product than our low resolution musket. I don't know what that is, but it's better than a musket, I guess. And I think it's like relatively easy to write these kind of front ends. Like for example, the Outlook one, I think maybe if you implement like 12 or 15 small JavaScript functions, you have the whole API basically. And then you just need to do some web development, which, you know, might not be pleasant, but it should be fine. Yeah. And so you can write some tools on top of these tokens to, you know, do AD recon, access Outlook, SharePoint, OneDrive, all of that good stuff. Yeah. And yeah, just an operational note, like when you use these, like in HTML like that, like you'd want to proxy it through a beacon that you have like in the client environment, right? So that any graph traffic originates from the client's machine or domain, not from your machine, of course. What about detections? Yeah, detection is not very great on graph. There is this really cool post by Fabian, or two posts, which I've linked here. He shows you like how you can collect the logs and do thread hunting and stuff. And I think that's a good start, but there's still a lot of work to do there with detecting malicious graph activity. And then before I close out, what I wanted to mention as well is like here we're stealing these tokens on endpoint. But if you do like device code phishing, like there's a project Token Tactics where you can generate links for device code phishing, then you also get like a token back. And that token can be rescoped, and like you can request a new token for graph, and then you can just plug it into all of these tools. So like, yeah, I just want to give like an overview of how I think you should approach like doing, you know, offensive security research or any kind of research really, and trying to refine the product for your end users. Don't make them suffer, you know, just give them something nice to use. And that's it. All right.